Hey everyone. What are you doing? What are you even doing? Like, where'd you get that? Okay, so he's got a bone, and that's not a bone that I usually give him. That's bizarre. I should probably redo this video. I don't really want to though. Today I want to talk about drawing angles and quadrants on the coordinate plane. It should be relatively quick. You should be able to draw some angles, but let's take a look and see what I'm talking about here. So here is a really nice picture of the unit circle, which we're not really at yet, but it's a really good, I guess, stencil drawing on how to draw our angles. Remember that we have the coordinate plane, our x-axis and our y-axis. This value here is going to be our initial side. It's where all angles begin. Positive angles go counterclockwise, negative angles go clockwise. So what are we trying to do here? Well, I'm going to give you a couple of examples, and we're going to A, draw the angle, and then B, identify what quadrant it lies in. So for purposes of our video, this is quadrant 1, positive, positive. This is quadrant 2, negative, positive. This is quadrant 3, negative, negative. And this is quadrant 4. Counterclockwise in nature. 1, 2, 3, 4. And again, rotations went this way in geometry, and in pre-calculus, trigonometric functions also go around this way, and angles as well. All right, so example 1. We want to draw a 60-degree angle and identify the quadrant. Okay, well, again, this point identifies where all beginning angles start from. It is the initial side of every angle. So we can really go ahead and draw right to the origin. Now, what does it open up to? Well, if this is a 90-degree angle here, 45 is actually this line here. And if you can kind of tell, all these sections are spaced out really nicely. You're not obviously going to have that on a quiz or a test, but I think that one of the things that's important here is if each part is 15, we can kind of eyeball really well here. That's 45, which means that this is going to be our 60-degree angle. And I know I went a little bit higher than we needed to, but that's okay. So this is our 60-degree angle. Now, obviously, this is a pretty simple one because we want to identify what quadrant it's in. And clearly, it's going to be in quadrant 1. So here's our 60-degree angle, and it lies in quadrant 1. Clearly, this video is not for angles that are like this. We're going to get a little bit more challenging with the angles. Sorry about the squeaking. Example 2. Draw a negative 190-degree angle and identify the quadrant. Okay. One of the most important things when we talk about identifying the quadrant and really drawing the angles in general is we want to keep it in the basis of 360 degrees, which is one revolution of our circle. Now, our reference points are just like the actual reference angles that we talked about and the coterminal angles that we talked about. We want to draw the negative 190. Well, in terms of 180, we know, first of all, the negative is going to go clockwise. But we know that the angle is certainly going to open up farther than this straight line, because this point, or its terminal end, would be 180 degrees. So negative 190 degrees is just a little bit higher. Not quite to this dot, because that's another 15. But it's probably going to be somewhere right around here. Right? Now, if I were to draw here, this bottom portion is that angle. It is the negative 190 degrees. We actually call this a reflexive angle because reflexive angles are greater than 180. Right? So it's going to fill in this section here. Now, where its terminal end lies represents what quadrant it's in. So when we say what quadrant is the angle in, we're not talking about the initial side. We're talking about its terminal side. So based on the drawing, what quadrant is this? Negative 190 ends up in quadrant 2. Right? So this was quadrant 1, and this is quadrant 2. All right. I think ones or angles that are between 0 and 360 are relatively simple to draw because we don't have to do more than one revolution. It's when we get more than one revolution that things get messy. Case in point, example 3. Draw a 400-degree angle and identify the quadrant. Now, Remember in a previous video we talked about one revolution being 360 degrees. Well, if we talk about things that are coterminal, it doesn't actually matter what the number value is of its degree if it's more than 360, because it's still going to terminate or have a terminal side at a multiple of 360. Huh? So if I want to draw a 400 degree angle, it would really be the same as taking 400, subtracting 360, and drawing a 40 degree angle. Because the 360 degrees is wherever that 40 degree angle lands, that's just one more rotation around the circle. So here's what we're saying. We're saying this: whenever you get an angle measurement that's greater than 360 degrees, or I guess less than negative 360 degrees, take a 360 degree out of the part of the equation. Meaning, get rid of a nasty 360 that I don't need, because it's still going to terminate, because that's the definition of coterminal angles. You see, that 400 and that 40, they're coterminal because they end at the same spot. The only difference is it just went one more time around the circle. So let's draw a 40 degree angle, and maybe we can visualize what I'm talking about. A 40 degree angle, if this is 15 increments, that's 30. So that's 45. It's not quite 45. So let's say our 40 degree angle ends here. This is 40 degrees. Now clearly if I said to draw a 400 degree angle, this would be wrong. But what is it exactly? Well, we always start at the initial side. I am going one full revolution and then ending here. So what did I do? I went one full revolution that you can't see because this blue marker sucks. And then I went an additional 40 degrees. Let's take it one more step. If I just wanted to draw a 360 degree angle, I start from the initial side, I go around one full revolution and stop exactly where I started from. That's 360 degrees. But because I want a 400 degree angle, I'm just going to go 40 more. It still looks like a 40 degree angle. But because, let's try another marker. Because I went around one more, it actually is going to look like another circle in here. Please work, yellow. You've never let me down before. Again, starting here. Oh yeah, there we go. It is actually going to be drawn that way. Starting at the initial side, going around the circle, passing where it started, and ending here. That is how we draw a 400 degree angle. Now, I think we can figure out what quadrant it's in. The terminal side of a 400 degree angle is in quadrant 1. This would have went a lot better if that marker worked. One more for you. We're going to draw a negative 655 degree angle. So let's go ahead and erase all this junk. Gonna see if this works. All right, I have a negative angle. I certainly have to go clockwise. Now, negative 655, it's far too big. It was at least one full revolution that I don't need. So let's take that negative 655 and add 360 to it, getting rid of an extra revolution that I don't need. That is going to give me negative 200. I'm stupid. I'm actually stupid. I'm actually freaking stupid. Okay. If it was 300, it would be 660, so it's going to be negative 295 degrees. Okay, now, negative 295 degrees is something that I can work with really well. It's not one full rotation around, but we can use our 90 degree increments of our unit circle to help us. Remember, I'm going negative, so I'm going to start with my units, or my unit circle, my initial side from here. 90 degrees, 180, 270. Each right angle is another 90 degrees of our circle. So 90, 180, 270. Well, I want 295. So it's a little bit more than that. Let's say it's about here-ish. Now, it's negative, so it's going to open up like this. But remember, the initial problem was negative 655. That means I've got to do one full rotation and then go back over to here. So I'm going to start right here. Doesn't really matter where we start on the line. I'm going to go one full time around and end back at this spot. That's 360 degrees, negative. And it goes up to here. So I start at my initial value. Because it's far greater than 360 degrees, I have to go one full revolution around to end where I started at. And then I'm going to go the difference in the distance to the actual angle that I opened up to. So here's what we're doing. We're finding kind of like the absolute here that we need. A value that's between 0 and 360, whether it's positive or negative. We're going to draw that angle. And then we're going to make as many loops as we need to. Sometimes you're going to need to make 2 loops, 2 revolutions around. This is going to look really spirally after a while. Moving on. What quadrant does the terminal side of negative 655 land in? And right here is our terminal side, and that's quadrant 1. Now, you might be saying to yourself, there's a lot of quadrant 1s here. It's true. Luck of the draw. Moving on. So, things to remember about this video. Number 1, angles between 0 and 360 degrees are actually really easy to draw. More importantly, they're really easy to identify what quadrant the terminal side lands in. Number 2, angles greater than or less than 360. So we're talking about angles that are bigger on the positive side or smaller on the negative side. They had at least one full revolution. And we can get rid of that revolution and still get the basis of that value of the angle. Because it doesn't matter where it is, that's the definition of coterminal. As long as the angles are coterminal to each other, we can go in as many multiples of 360 as we want, or for this video and for this concept, we can get rid of or subtract out as many 360s as we want, because the angle will end in the same exact spot terminally. Bark, bark to yourself too, sir. And finally, number 3, it might be helpful to estimate where the, he did not like that. It might be helpful where to estimate these values from every right angle of the coordinate plane, where we have a 90-degree angle, 180, 270, and 360. If we think about it in terms of 90s, right angles, it might make our life a lot easier. See you next time.